what happens when there's multiple chain rule in your chain rule? So for example, here's the derivative of e to the sine of x squared. Well, this is e to the stuff, but in my stuff, there's even more stuff with the x squared. So, let's start working this out. The derivative of e to the stuff is e to the stuff times the derivative of the stuff. I'm going to rewrite this as the derivative of sine of stuff. Because when you take the derivative of this stuff up here, we have to use chain rule yet again. Because our stuff is really sine of stuff. And when we take the derivative of sine of stuff, well, we have to use chain rule. The derivative of sine is cosine of stuff times the derivative of the stuff. And here is the full answer. 2x cosine of x squared e to the sine of x squared. One way to think of this, without having to rewrite the derivative yet again here, is the derivative of e to the stuff is e to the stuff times the derivative of this stuff. But within this stuff, we have yet more stuff in the x squared. And the derivative of sine of stuff is cosine of stuff times the derivative of that stuff, which is 2x. So in reality, when you have multiple chain rules in one problem, you can think of this as unwrapping an onion. And with each of those layers that come off, we unravel the chain rule a little bit more at a time. Here we are asked to find the derivative of 1 over the natural log of x squared. Well, first, we can rewrite this in a way that's more visually appealing. We can rewrite this as the natural log of x squared raised to the negative 1. In this way, it's obvious now that we have stuff to the negative 1. And the derivative of stuff to the negative 1 is negative 1 stuff to the negative 2 times the derivative of the stuff. But my stuff here is the natural log of even more stuff. So I have to find the derivative of the natural log of stuff now. And the derivative of the natural log of stuff is 1 over stuff times the derivative of the stuff. And so, one of our x's cancels out. We send our natural log of x squared quantity squared down to the denominator with the x. And here we have negative 1 times 2 on top, that's negative 2, over x times the natural log squared of x squared. And this right here is the derivative. If f of x is equal to sine of e to the negative x, then f prime of x is equal to, well, here we have sine of stuff. The derivative of sine of stuff is cosine of stuff times the derivative of this stuff. But here we have e to the stuff. And the derivative of e to the stuff is e to the stuff times the derivative of this stuff in here. The derivative of negative x is just negative 1. And so our derivative here is negative cosine of e to the negative x times e to the negative x. The derivative of the natural log of the absolute value of cosine of pi over x, well, here we have the derivative of the natural log of stuff. And the derivative of the natural log of stuff is 1 over stuff, that's 1 over cosine of pi over x, times the derivative of cosine of stuff. Now, this pi over x in here, this is really cosine of pi x to the negative 1. Let's consider that. So we have the derivative of cosine of stuff is negative sine of stuff, that's pi over x, times the derivative of the stuff in here. The derivative of pi x to the negative 1 is negative pi x to the negative 2. So here, let's make this look a bit nicer. We've got negative 1 times negative 1, that cancels out. We've got a pi on top. We've got a sine of pi over x, so we have pi sine of pi over x. In our denominator, we have our x squared and the cosine of pi over x. Now, sine over pi over x divided by cosine of pi over x, that's just tangent pi over x. So our answer here is pi tan pi over x over x squared. And last but not least, let's take the derivative of e to the tan squared x. Tan squared x throws a lot of people off, but we can rewrite this as e to the quantity tan of x squared, because tan squared x and tan x squared really mean the same thing. And visually, this is a bit more appealing if we're doing chain rule. So f prime of x, here we have e to the stuff. The derivative of e to the stuff is e to the stuff times the derivative of the stuff. Now my stuff here is tan x quantity squared. Well, that's stuff squared. And the derivative of stuff squared is 2 times stuff times the derivative of the stuff. And our new stuff now is tan x. The derivative of tan x is secant squared x. And so our derivative here is 2 tan x secant squared x e to the tan squared x. And that's the answer.